Alright, so I'm just going to quickly go over the answers to my online Organic Chemistry 1 Quiz 2 from the spring of 2025. And my approach to things like this, honestly, for like identifying functional groups, you really do just need to start to get used to recognizing them. But a good clue at this stage is finding anything with a heteroatom. So I'm just going to, and what I mean by heteroatom is anything that's not carbon or hydrogen. So I'm just going to circle any heteroatoms I see. So like this oxygen, this nitrogen, this oxygen, but it's connected to another one, so I'm going to circle this whole thing, this chlorine, and this oxygen. So I've circled all the things that are suspicious that are not carbons and hydrogens, and then I'm going to go look at each one and say what I think it is. So this one right here, this oxygen, is a double bond to a carbon, and so the oxygen double bonded to a carbon is called a carbonyl, and there's a few functional groups. I'm actually going to do this on a skinnier pin. This right here is called a carbonyl, and there's a few functional groups that contain that carbonyl, carbon to oxygen double bond. One of them is a ketone that has a hydrogen specifically, and then it can be any carbon chain on one side. Another is an aldehyde that has a carbon-oxygen double bond, but, I don't know where my brain is. A ketone has carbon chains on both sides. An aldehyde has that carbon-oxygen bond, aldehyde, but one side has to have a hydrogen and the other is any carbon chain. Then we also have carboxylic acids, and one side has to have the OH group, carboxylic acids, and then amides, and that has to have an amine on one side. So if I'm looking at this carbonyl, that gives me a good clue that it's going to be one of these functional groups, one of these. But when I look at what the carbon-oxygen is double bonded to, or is bonded to on the other side of the double bond, we have two carbon chains, a carbon chain here and here. So that to me looks like a ketone. So it's a carbonyl, but more specifically, it's a ketone. Then we see another carbonyl over here, but it's a carbonyl with one of the sides being an oxygen with a hydrogen. So that to me looks like this carboxylic acid. So that is a carboxylic acid functional group. So starting by identifying any heteroatoms or like anything that's not carbon and hydrogen, and then trying to compare them to the list of things you know. The next thing, since we're already on oxygens, is I see two oxygens, one right here and one right here. One oxygen has a hydrogen, so this OH, oxygen with hydrogen, is an alcohol. Whereas over here we have an oxygen with carbon on both sides, and an oxygen with carbon on both sides is an ether. So I would call this one down here an ether and this one an alcohol, and I think that's actually, is that all of our functional groups with oxygen? I think it is. So we've covered all the functional groups with oxygen, and we've covered all the functional groups with oxygen in our structure as well. So now we look at an N for amine. So we have either an amine, that's an M, or an amide when we have a nitrogen involved. And it looks like we have the amide structure down here below, and that is not what this one up here looks like. This looks like just a nitrogen with 3 R's on it, and that is an amine. So I'll come down here to the left and do a quick review of amines. They can be NH3, they could be NH2 with an R group, or carbon chain is what R stands for. NH with 2 R groups, or N with 3 R groups. So all of these would be amines, and then based on how many carbons are substituted from this first one, if we have 1 carbon, that's a primary, 2 carbons, that's a secondary, or 3 carbons, that's a tertiary. So what we have is a nitrogen with 3 carbons up here, so I would call this a tertiary amine, not an amide. And so that's everything except this one, this chlorine, and chlorines are halogens, and when we have halogens bonded to alkyl groups, we call that an alkyl halide, halide for halogen, or if we're being specific in this case, it'd be an alkyl chloride. And alkyl chlorides can always, typically, are just going to have one bond. I'm going to erase this bracket over here. They are typically only going to have one bond to a carbon, because halogens like to only have one bond. So we don't just, if we're trying to say how substituted it is, we don't just look at this carbon right here and say it's bonded to one carbon and it's primary, because then they would always be primary. So instead we have to look at what are those, the carbon that the halogen is attached to, I call the point of attachment, and how many carbons is the point of attachment bonded to. And in this case, our point of attachment is bonded to 2, so I would call this a secondary alkyl chloride. And then same thing with the alcohol. Typically alcohol is bonded just to one carbon. That's the nature of the functional group. It's just one carbon bonded to OH. And so we look at that point of attachment again, and how many is it bonded to, and this is bonded to just one, so we would call this a primary alcohol. So for this question, it was worth 15 points. And you got a point for each one of the functional groups. So 1, 2, 3, 4, 5, 6 functional groups, so that's 12 points. And then there was an extra point for the 3 that you had to say primary, secondary, or tertiary. And that was that. Okay, the next one we're looking at is going to be cis and trans bonds. So for cis and trans bonds, that is anytime you have an alkene, if the hydrogens are on the opposite side, we would call that trans, or the same groups or the larger groups on the opposite side, that's trans. And then if you have them on the same side, and then the substitutions, the R groups, whatever, on the same side, we call that cis. So the way I find this, I typically will just draw a line right down the middle of my alkene, and then I circle the hydrogens, and if the hydrogens are on the same side, it's cis, and if they're on the opposite side, it's trans. So I'm going to do that right here. I'm going to draw my dotted line right through my alkene, and then I'm going to circle my hydrogens. So I have a hydrogen here and a hydrogen here. These are not on the same side of the dotted line, so I would call this a trans double bond. Now this other one, this is trickier. I'm going to draw in my hydrogen, but I only have one hydrogen. And then I notice that these two groups are both CH3, which means they're the same. So if I were to swap those out and trade places, the new structure would look like this, which means it's the same. So that means we don't have a cis and trans version, because even when I trade the places of one side or the other, I get the same molecule. So it's not capable of cis-trans isomerism, so I would say neither on this one. On cis-trans isomerism, if we trade two sides out, like you can clearly see in the example I gave here at the bottom, if we trade these two sides out, it becomes a different molecule. But if you don't trade the two sides out, if you trade the two sides out and nothing changes, then it's not a cis-trans isomer. Okay, well, I hope that was helpful, and you can use this as a study tool, and let me know if you have any questions, and I will do my best to answer them. Good luck studying.